الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. So we'll be continuing with our discussion as far as the different types of studies are concerned. We are already aware that about the table, what are different types of studies, number one. Number second is that we already finished one, that the descriptive one. So what was the purpose of descriptive one? How does it work? Okay, Thursday's lecture. So the point that was that what we did in the descriptive epidemiology or descriptive type of study, we just observed as the disease occurred and we put it in three parts, like percentage, how, or the persons who are involved, where is the disease occurring, and what was the third point? Time. And time, when is it occurring? Yes. So in all these parameters or dimensions, we try to find out that how does the disease pan out or fan out. Then we also understood that this descriptive epidemiology, it helped us to understand or to give us some idea about certain factors and disease. So what we meant by that is that it helped us to generate a hypothesis that these might be the reasons for this disease. But in the second part, which is also a part of observational studies, we know there are observational and experimental. In observational, you have descriptive and analytical. The second part of that observational is the analytical studies. In this analytical studies, we want to answer one important question. Why are the people developing? So we want to know the reasons for that. And we have very rich material coming out from the descriptive epidemiology. That is what we want to test that hypothesis, whether that hypothesis is correct or not. So this should be our broad idea when we'll be talking about these analytical studies. And you in your research can pick up any of the designs, because you are also carrying out your research, inshallah, in third year, but you are planning not this year. So when you plan, you should understand that what should I choose, which design I should choose. So let us go with this part. So the outline is that key messages, why we want to have those study designs. Key message, important points, blood marks. Second, types of epidemiological studies. You know already about this. We have given the table, and the same table will be again, so that it will be again banged against it, and you remember it forever. I don't want you to forget it. You will remember it forever. Then we'll be talking today about the first two types of analytical ones, the study designs. One will be the cross-sectional, another will be the case control. So we'll be talking about these two designs, that how we carry this type of study, what we do in this. So first important thing is that in your research, this is the crucial step. Whenever you will do a research, to adopt a particular design is the crucial step. So we should know each and everything about different types of design. What should we choose? Which design I should choose? And you should understand that no design is perfect. Every design has certain strengths, they have weaknesses. As all of us have. All of you have certain strengths, but there are also weaknesses with us, isn't it? So same is the point when we are talking about designs. No design is perfect. They have strengths, they have weaknesses. So that's to be kept here. Then, epidemiologists must consider all sorts of bias and confound. We will see in the proceeding topics that what is this confounding, what's this bias, why we should be worried about these two things. Then ethical issues are important. Whenever you will carry out a study, the ethical issue is very important. Ethical issue, you know what's ethical issue? Any idea? So you need to have first an approval of the study, then you need that the people who will be in your study, you need to have an informed consent. You cannot take people for granted. you have taken informed consent. You have tell them what the type of study, why you want to carry out the study, what will happen to the person who will be a participant in your study. So that's why it becomes important to have ethical considerations in mind wherever you will be carrying out the study. Now this table is over, but I want to keep it all the time till the end. Once we are finished up with the epidemiological design, this will be there always. So that this will be now in your dreams also, you'll be finding this table again and again and again. Isn't it? So when you find it in your dreams, you remember, inshallah. That means there's something bang over. So we have observational and we have experimental. Observational means you do nothing. You just observe. Like I will observe you, I will do nothing. But if I have to do something, interventional, taking a blood sample or giving a drug or anything, giving a drug especially, not sample, but giving a drug, medicine, new medicine, that will be intervention you should be doing. Or I may be saying that we have certain people like Anas and others who are malnutrition, nourished. So I will give some important diet to them. I will give a different diet to them. You are not. But if I give some diet to him, so that's an intervention. I'll be giving some particular type of diet, while others, they will continue their routine diet. Okay, for we have a friend here, he's very much obese, so I will give a different type of diet to him with respect to others. So I'm doing an intervention. So, but in observation, I'm not doing anything. Is that clear?
Yes.
Now this part, it generated the hypothesis, the descriptive. This part, it tries to test that hypothesis. Now what's important for any type, all the diseases, you have sometimes, for example, tuberculosis. What is the cause of tuberculosis? Mycobacterium tuberculosis, isn't it? What are the food poisoning that occurs within 1 hour of eating a food? The most important organism is a staph. Okay. But how does this come from? Similarly, we have diabetes. Now, what is the cause of diabetes? Do we say cause of diabetes? What do we say? What are the risk factors of diabetes? So these two important things we'll be discussing. It's called as the cause-effect relationship. Cause and effect. Like you have a lamp. If I put that switch on, it will glow. So that was the cause, and this is the effect. Are you getting my point? Similarly, if I have a risk factor, and then I get a disease, the risk factor is we can say that many of the causal factors, and effect is the disease. So what in medicine or in any subject, you are only studying the effect. The disease, this disease, that disease, that disease. But what we are trying in epidemiology is to find out the reasons why. That is the big why. Why do they get the disease? So that is, we are trying to find out the cause-effect relationship. So, obesity, we say obesity is one of the causes for diabetes. One of the risk factors, not cause, risk factors for diabetes, isn't it? But we try to find out the association between the two. That means, what is association? Association means when we see the disease and the risk factor together more often than by chance. For example, what does that mean? It means that if you have 15 people who are obese, and out of 15 people, 13 are getting diabetes, 13 are having diabetes. That means the obesity is not by chance with them. There's some association between the two. So that's what we call as association. Association means when the two factors are seen together more often than by chance. So understand these terms. These are very, very important terms, and just you have to put some string in your mind that how we basically go to this point. Now that's called association. And all these analytical studies, they try to find out, is there any association between these two factors, between risk factor and disease? Is there any association? And if there is an association, then what is the strength of association? How strong is this association? Or in other words, how much this particular factor contribute to the development of the disease? Are you getting my point? Because it's not difficult, but the point here is you are used only to diseases, diabetes, tuberculosis, hypertension. But what we as epidemiologists are concerned is what are the reasons for that? You get my point? What are the factors that lead to that? But how we reach there is because of these carrying out these types of studies. Is that clear? So association is when the two factors we see together more often than by chance. So they are not together by chance, they are seen together always. So when this thing happens, we say this there is an association. And these analytical studies try to help us to understand that if there is an association, how strong is the association? How strong is the association? Like you have seen the first year students, there are two students, they're always seen together. If you see them, they are in the salah, they are together, in the study, they are almost close. So there is a very strong association, isn't it? Because they are Tavian, so you are finding them together, always finding them together. This is called an association, and this is a very strong association. Are you getting my point? So similarly, when you have a disease, when you have a factor, you are seeing them together, then you see probably this might be the reason for that disease. One of the reasons, if not the only reason. One of the many reasons. So with this today's topic, we know it, so I will not discuss. So now, at the end of the day, you come to the department. So please tell us which slides are delete. So do you want to keep this slide? You don't want. So you already know that this will not be in your. From this, nothing will come. When people are coming to which slide I should delete. This is this. This is not fair. So I say we have talked about this. Now let's go to the design. How does we proceed with this type of study? Please understand, I said cause and effect. Cause and effect. Effect is the disease, and cause are the risk factors or the etiology of this disease. But when we take this type of study, if you are planning to have this type of study, what you do? So you try to identify, the name is case and control. So you start your question or your study with cases, with those people who already have the disease. Cases. So you are picking up in your study the diseased people, and then you are trying to go back into history to find out the cause. So effect has already occurred. So people are already diseased. So when you choose those, then you go back and see how many of them are exposed to a particular risk factor and how many of them are not exposed to that particular risk factor. Is that clear? So we start from the people who are diseased in a case control study, and then we go back into time and try to find out that what was the probable reasons for that disease. So our study here, the case control study, it starts from having cases, by enumerating cases. Now this case can be a case of breast cancer, and you are going back to see what are the risk factors. And among the very important risk factors is oral contraceptives. So you will go back and you will ask them the history. Have you taken oral contraceptives? How often have you taken? Okay, this will be about the cases. And there may be few cases who have not taken it at all. So that means some people may be exposed, which you are thinking that this might be the risk factor, this might be the reason for the disease, and some may not be exposed. They have got this disease because of some other reasons. Are you getting my point? So when you choose these cases, then how we say that they have developed basically the disease. For example, I will tell you, if we have a group of smokers and we follow them forward. Now this is backward. Now we have smokers, we follow them forward and see that how many among these smokers they develop lung cancer. But the question is, if they have not smoked, what was the chance of having the smoke? What was the chance of not having the lung cancer? Now, if we have a group of people here who are smokers, then we follow them for development of the bronchogenic cancer, the lung cancer. But how can you put them back into the time machine and say that if they would not have smoked, would they develop disease or not? It's very difficult. Yeah. So to answer all these questions, we have different designs. This is one of them. So this tries to find out from the effect, it goes back to the cause. So you see the direction of inquiry. That means you are inquiring something. You are investigating something. But it goes backwards. Direction goes backwards. But this exposure leading to disease, it is time. It goes this way. So this type of study, we call it as a retrospective study or a backward-looking study. It starts from the effect and tries to find out the reasons for that effect. From a disease, trying to find out the reasons for that disease. Risk factor. Is that clear?
Clear.
But we take two groups.
Yeah.
One group who have the disease and try to see that how many of them have actually had the risk factor or exposure. That we call exposure.
That's
And how many of them do not have. Similarly, we take another group who do not have the disease. You see? We take another group who do not have the disease, and again we try to find out that how many of them have actually exposed to that particular factor and how many of them have not. Then we try to find out whether this risk factor increases the risk of disease or not. That's how we do deal with it. So is that clear? So in case control study, we start with cases and another group with controls.
Yeah, because you mentioned retrospective study. You have to mention the difference between case control and retrospective. Because case control, you have to compare between two groups, cases and controls, people without disease. In retrospective, you have only to focus on only group. Only one group, which have the disease.
Problem here is that once we will move forward in the lectures, you will come to understand one of the terms as cohort. Now they put it like this. This is an old method. One of the ways is by having a group of people and following them in future.
Yeah, prospective.
This is called a prospective study or a cohort study, which we'll be dealing in next lecture. But if you change the name, previously it was this type of disease was called as TROHOC. TROHOC means retrospective, going back into study. We will deal with it in parts. So what is important this time is that for all of you, what is important, that it's a retrospective study. It starts by identification of cases and identification of controls. Then we see that how many among them are exposed and unexposed, and also in this group how many are exposed or unexposed. We'll come, but it may be useful for you, it may not be useful for many others. So when I talk, I have to talk which is more important for all of you. Okay. If you have some additional information you need to know about this, you can come back to me and talk. Because what I will be talking about the case control is the basics. Now in the case control study, what are the types of case control studies, then it becomes very difficult for me to understand. It is a postgraduate, a topic for postgraduates. What is the nested case control study? What is the case cohort study? It's very difficult for you at this level. So we'll be very brief, and what is important for you, what you should have big things with you. Because we need big things with you to carry in future. And then you can refine them up. So I said that it starts from cases and it also starts from controls. So we have cases and we have a group of controls, and we are looking backward from an effect, that means from a disease to the cause. Okay? You can see, I have given the colors. You will see that these group among the cases are actually exposed. We are trying to find out which are exposed, which are unexposed. And in the control group, you will see exposed and unexposed. That's what we are trying to find out. So, our study, these analytical studies, whether they are cohort, they are cross-sectional, they are case control studies, ecological studies, they try to find out that is there any association between two factors. That means between a disease and between risk factor. That's what we are trying to find out. And if there is, what is the strength of association? How strong is this association? In case control study, we calculate this. That's why I say I will keep it simple. Odds ratio. We'll only calculate odds ratio from a case control study. So whenever you will have anything or somebody talking about odds ratio, you should immediately understand that it's a case control study. He has started with cases, he has started with controls, then he has gone back to see what were the reasons for that, and what he has calculated is the strength of association, and this strength of association is the odds ratio. So at least if you know that part, I'm satisfied that you have something in your mind. I have been able to translate or transfer some part. So it's also called as, so it is not important when you come tomorrow, is this slide important or not? So you already understand it. It's not important if you have understood. If you have not understood and you want to go for a, like we do every time, without understanding most of the non-Arab countries who do not know Arabic. We don't know Arabic. We can read, but we don't understand what it tells us. So we go for just subhanallah. Repeat and repeat and repeat. But you are not understanding what does it actually mean. Or even the Quran, if you take any verse, what it actually means. So we go back and see the translation, then we understand. Because we are non-Arabs. So when you come to me, so you will not do that non-Arabic subhanallah, you will do your subhanallah, because you know that this slide is not important. Is that clear? So nobody will come to me that whether this slide is important or not. So you already know it's a retrospective study. What else you want to know? Finish. So this it goes off. So what we are looking for, risk factors in already developed. This is very important because we started from cases. So effect is already there, disease is already there. We are trying to find out what are the reasons. Anybody has problem till now? Is clear?
Yes.
It's great if it's clear. So what we do in a case controls, how do we carry out? So if you choose this type of design, so what you will do? The first thing which you will do, you will go for selection of cases. So which case I will take? Should I take bronchogenic cancer? Should I take breast cancer? Should I take diabetes mellitus? Should I take any other disease? Whatever you know. So what type of disease I will take? And the cases. Because it starts from the cases. And sometimes you have breast cancer. You have different stages. Stage 1, stage 2, stage 3, isn't it? So you may limit only, I will take stage 1 breast cancer. Or you may say, no, I will take stage 4 breast cancer. So you should be clear that who you are considering as your cases. It should not be that you have a loose definition of cases. You should have a very simple and straight and correct definition of the case. Is that clear?
Yes.
Then you should also identify the source of control. Now, why we want to have controls? Because these cases have been exposed to some particular factor. They are coming, for example, from Sakaka. Now, what was the level of exposure of this factor in the whole population? That's why it's important to have controls. So we identify the source of control. Second, then we have to have another group. What is that group? Control group. So we have two groups, cases, and second, controls who do not have the disease. Then third thing is, we do something called as matching. We'll see what matching is. Then we try to measure, compare the exposure between these controls, between these cases. We'll see how we do that. And then we go for data analysis. So these are the steps which, if you try to have a case control study, these are the steps. So the first step is selection of cases. So if I tell you what are the steps in a case control study, this is very important. And if you understand, you did not remember it. You did not remember it. You need to remember it? No. So selection of cases, identification, source of controls. Selection and source of controls. How you select and what will be the source. Matching, then you try to measure the exposure in case as well as controls. Then you go for data analysis. So these are the 5 steps which we do. So, as I said, when you say cases, what case? Which case? Specific. It should be valid and reproducible. That means if you apply it again, it should again give you the same case. That's what you mean by reproducible. Valid, it should measure what's intended for it to measure. So it's little bit, it will take more time if you try to explain all these. But what you need to understand that my case definition, which I will put in place, should be clear, should be specific, it should be valid, and it should be reproducible. For example, the case definition may include the diagnosis and the stage, as I said. Are you taking stage 1, are you taking stage 2, are you taking stage 3, or stage 4? What? Eligibility. So that will tell us, are you taking only males in that or females in that? For example, if it's a diabetes. Okay? Even for breast cancer, you may take males and females, isn't it? Males also develop breast cancer. Many people may think, no, how can we do that? Are you getting my point? So you have to say the eligibility
We cannot
criteria.
collect them in one study, yes?
Huh?
We cannot collect them in one study.
Males and females.
The cases have already occurred. You need to identify. You may go to hospital and see breast cancer case, how many are there.
Okay, but when you said we have to care about criteria, so we cannot make one study for both male and female breast cancer.
That's what I'm saying.
Yeah.
This is your choice. Whether you are studying only the female breast cancer or male breast
Okay,
cancer.
okay.
That's what I say. Your diagnosis and definition should be clear. What are you picking up and what is your diagnostic criteria? And where from you will get those cases? They have already occurred. So you need not to be panic about it. It's very easy to find out. Maybe in the hospitals here, in another hospitals, so they are already there. Or you may need to find out them in the community. They have already occurred. These cases, the disease cases have already occurred.
Yeah.
So you are trying to pick them up and see their history. From the history or case sheets in the hospital, you may have case sheets, case diaries for them about exposure. So you need to pick up information on that. So it's very easy, isn't it? We will see the advantage of this case control study. So one thing is that it's the most easiest one. It's economical. You don't need so much money for that. You just go to the hospital, see how many cases are there for this year, pick up those cases according to your stage, according to your diagnosis. So they have occurred. And you have case sheets available. You have only to take the record from that.
Well, Doctor, you can study both groups according to your definition of your study,
Which groups?
male and female breast cancer.
That's what I said. That if you have to be specific what you are talking about. If you are taking males, it will form one group of cases. If you are talking both, then males and females, males will form one group, females will form another group. But the reasons for the disease or the risk factors are different,
Yeah.
isn't it? So you can choose the best option is that we choose one group and then follow backwards and then see backwards what is the history. So where from you will get the cases? Or from the general population. So it's simple. Cases have already occurred. So this is not important slide, huh? By the way, let me tell you, this is not important slide. So you should not come to me for crossing it. For what? Now, I say the controls. Now, I have to be this is a very important step. Because the controls and the cases, if they come from the same population, the cases come from a defined population, I have to understand that what was the level of exposure of this risk factor in the population, which gave rise to these cases. That's very important. Was it, for example, if there was a 20% prevalence of smoking in this population, that gave rise to cases? Okay? Or is it 50% prevalence that which give rise? So these cases, where from it comes, you have to take the controls from that to understand that they have the same level of exposure of the particular type of disease. So the controls should be similar to the cases. Controls should be similar, but not with the disease. Please understand that controls do not have the disease. They should be similar to the cases except for the disease. So not disease. Definitely cases are with disease and controls are without disease. Population of an administrative area where from you will get it. For example, you have hospital versus administrative area, you can take it for only Al-Jawf region. Hospital patients. Sometimes you may take the case of breast cancer as your cases in your case control study, and the controls can be other diseases. For example, renal failure, for example, diabetes, for example, hypertension. So you can take the controls who do not have this type of disease, because you are studying which disease? Breast cancer. So the cases should have breast cancer, the controls should not have breast cancer, isn't it? You should be free from that. So you can take any other case other than breast cancer. So that will be your control for this case control. So you can take from the hospitals or relatives of the case. For example, the sisters, the mother, the cousin of that female, they can act as control for that case, for each case. So this is very important slide. Huh? Now you should not tell me that tomorrow again this is important. This is important slide. Or sometimes you have certain diseases, spouses. For example, I'm a smoker, I develop a lung cancer, you may take my wife as a control. Me as a case, my wife as a control. Because when I was smoking, there was some exposure even happening to her. Okay? So that's why it's sometimes, if we do not find a control, we can take spouses as a control. Or we can take even siblings. For example, we have now the twins, which you are talking about. If one twin develops a particular type of disease, the other didn't develop, the other may be taken as a control. Or you can take the neighbors from the same and general population. Or you can take the general population from which it occurs, from which the case is generated. So this is how you take the controls. Controls are people who do not have the disease. Okay? Should be clear.
Yeah. Spouses, please.
Huh?
Spouses.
Spouses means me and my wife. That's a very simple thing, no? Now another thing is, the third important thing was matching. Now, if I am taking the cases as, yes man, you have any problem? If you have any problem, you can leave out. It's open. We don't force anybody to sit back. Now, matching is a point. If I am studying breast cancer cases among 30 years and older females, and I am taking another control who do not have the disease, and I am taking those females of 5 or 6 years. Is that a control? Is that a control? Why it's not a control?
Age.
Very good. Age. Age is one of the reasons. The second, so that means these cases and the controls should be comparable. They should be almost comparable except for the disease. That they are disease, they are not disease. But the other factors, they should be comparable. They should be matched. For example, if I am taking breast cancer for females, I cannot take a male control. I have to take the female as a control. But the female should be of the same age because age is one of the risk factors for developing breast cancer.
Because they don't expose to the same factors.
They are not exposed to the same factor. So the reasons why we do matching, if I do not do matching, now what will happen? If I take small females and females who are more than 30 years of age. Now these 30 years of people, females, age is one of the risk factors for developing breast cancer, isn't it? Another thing is, those smaller babies, they have not taken oral contraceptives. This female has taken oral contraceptives. So if I will not match that, it will lead to confounding. Now what's confounding? Confounding is a factor which is common to both disease as well as exposure. That means this factor is itself an independent risk factor for the disease. For example, we have oral contraceptive pills as one of the risk factors for the disease. Age is another factor for disease. Nulliparity is another factor they may develop breast cancer, isn't it? So if I am studying only the OCPs, the other two I have to match. If I do not match, these might be the factors that might be leading to breast cancer. And when I get the results, they may not be the correct results. It will lead to confounding, distortion of results. So what I say, matching is done to ensure comparability, that the two factors are comparable. For example, what does this comparability? I will give you a simple example. Now I have this person here who is a very healthy person. I'm putting him to fight against answer. Are they comparable? Are they comparable? No, they are not. So I have to put a similar person for him to fight with. So that's comparability. You are not. That's comparability. So otherwise it is destined that Anas will lose. So what is the result? So our results are already biased. There is a confounding that he is a malnourished person. He will. He is over. He is over. So obviously not. So confounding is a factor that is independently associated. So age is independently associated with the development of risk factor. Nulliparity, who do not give birth to any baby, they have a risk of developing breast cancer. If I will not match that and distributed unequally, if I will not compare them, then they will be unequally distributed, and this will give a result which will not be a valid result. So matching is done on known factors. Please understand, because it's very important. matching is to make the two groups comparable, but this is done on known factors, which we know that they are the risk factors, independent risk factors for the disease. So we match them. For example, age, we know age can itself lead to gender, education level. If you have poor education level, there are more chance of developing the disease. Birth order, socio-economic status, all these are independent risk factors for developing breast cancer. If you have not matched them, then it can lead to confounding. So, we do this matching on known factors. Understand this. And when I will reach, inshallah, to randomized control trial, I also do the same thing, but that is not called matching, that's called randomization for unknown factors which I do not know. So now this, how can you control this confounding? As I said, we will control it at the design part, when we are designing. That who will be my cases, who will be my control. Age group wise they will be same, gender wise they will be same, smoking wise they will be same. Okay? Except for the disease. One group will be having disease, another group will not be having disease. So that's called as matching, which we did. We can also restrict. That's called restriction. We will see in another topic. So this is not here important, but this is just giving idea. So it will be a separate lecture will be on confounding and bias. So we also can control this confounding by randomization in RCTs, which I showed you here. This is done for the. This is done. Matching is done for known factors, and randomization is done in RCT for unknown factors to control this confounding, so that this problem should not happen. This problem should not happen. But we can also do at the analysis part. If when we are doing a statistical analysis, we are analyzing the results. When I get the data out of that, I can do stratification and statistical modeling. This is not for you, but in future, inshallah, I'll be talking about that. So here, this slide is not important here, but it will be important in the lecture of confounding and bias. Then step 4 is to get the information on the exposure. Now, how will you do that? You can just, if you have the cases there in the hospital, you find out the breast cancer cases, you will go back into the data of the case sheets and try to see whether they were smokers, whether they have taken OCPs or not, or whatever data you want to collect. Or the other way around is, you can interview the cases. Have you taken this thing, have you taken the, which are known risk factors. So that is what you will be trying to interview, eliciting history of exposure. Or you can give a self-administered question to the case as well as the controls. Hospital records, which I said you can search the hospital records and put it what are the reasons. Clinical examination, sometimes you may have to go for clinical examination or a lab investigation to find out the exposure and its measurement. Then step 5 is data analysis. So now you have got the data on exposure for both cases as well as controls. You have got it. Now what you will do? You will try to find out is there any association or not. But how will you do that? I will tell you in the next slide. So what you are calculating is an odds ratio. This I will leave. This I will also leave, not for you. So now you have the cases. You have the controls. Okay? So these are the group who have risk factor. So risk factor is also present among the cases and some members of the controls. Risk factor is absent in some of these cases and it's also absent among the controls. But these are the cases. The C is the case. A and C are the cases. So these were the cases. Some of them have the risk factor, some of them do not have the risk factor. Are you getting my point? So what does that mean here? That means this is not the only risk factor. There may be other factors which might have led to this problem. In other words, disease is multifactorial. That means many reasons. There are many risk factors. You don't have only one risk factor, many risk factors. So this is giving us the concept of multifactorial causation. We have read this multifactorial causation in year 1. Okay? So similarly, we have controls. Among the controls, you have some people have this risk factor, some are exposed, some are not exposed. Now when we calculate it A into D and B into C. The odds ratio A into D, B into C. This is called as, this is cross product. Cross product ratio. It's also called cross product ratio. I will give an actual example. I'm not giving other things in it, like exposure odds, exposure cases. I'm not dealing with that. Give you a big idea. Then you will go back and see your, I have given you the e-book. You can read and you can come back. Oh, this you have not taught. Yes, I have not taught that. You have to read that. For example, now we have lung cancer cases. These are the lung cancer cases. How many cases are there total? 50. Out of 50, how many were smokers? And how many were non-smokers? Among these who are controls, how many were smokers? They did not have the disease.
Yeah.
That means these are the control group. So 60 were not smokers and 90 were smokers who do not have. So when we take the odds ratio, so it's this multiplied by this divided by this multiplied by this, it comes equal to 6.0. If you calculate it on your calculator, you will find it. It is 6.0.
Dr. Shota, you already mentioned the control should be similar to the cases, yes?
Similar in what?
Not in the disease, but how about number?
How much is the number for the case? 50. How much is the number for this? 150. Means I have taken one case and I have taken 3 controls. Usually what's done, this is, we have picked up it very beautifully. Usually for case control study, we may have one matched one. That means if you have 50 people, we have 50 controls. But that's not always good. You will not get a perfect control. So what you are trying to do, you have 50, you may have 3 times the control, 2 times the control. So that's what's happening here. This is 3 times the controls. That's why it's becoming a more picture, more increase in number as compared to cases. And what you are getting the odds ratio? 6.0. What does that mean? What does that mean? Now we come to the bottom level. So now we say that those smokers or the smoking, those people who smoke are 6 times at risk of developing the disease as compared to non-smokers. Is that clear? So simple. Or difficult? So odds ratio tells us that this association between the 2 factors. Now we are seeing the association between smoking and lung cancer. But how strong is the association? Means that if I am a smoker, I have 6 times more chances of developing lung cancer than a non-smoker. You got the point? So this is the strength of association. Clear or difficulty? Clear. Good. So as I said, these epidemiological studies, especially the case control study, there are 2 problems which you get. Number 1, confounding. How we did that? By matching. So 2 problems arise in this type of study. Number 1 is the confounding. We dealt with confounding by matching and also by the study design and at the analysis part, by restriction, matching, or randomization. And the slide which I said is not important. But there is another problem that can happen is bias. Like Vasta, like Anas is also coming to me and Saleh is coming because Anas is a very good friend of mine. I'm giving a few marks more to him than. So this is called a bias. You see Vasta in Arabic?
No.
But the problem arises also here. But here this is not the Vasta of that kind.
Means تحيز.
Huh?
تحيز.
This is called Tahi?
Yeah, in Arabic word تحيز.
Okay. I don't know. But we also say Vasta, no? This is a common term which I have been hearing. I'm not an Arabic speaking person. So what I hear, I speak that for now. So sometimes problems occur in the case control study, especially number 1 was confounding, number 2 is the bias. Now, what does that mean? Sometimes bias due to confounding factor is a recall bias. For example, if I am asked, we have cases now, Same cases, lung cancer cases who are smokers and the non-lung cancer cases, which are controls. When I ask them about the history of smoking, the person who has the lung cancer, he will immediately realize, yes, I was a smoker. I have taken smoking I was smoking for this period of time, now I left, for example. But the other person who doesn't have the disease, he need not remember that. You are getting my point? The person who has not the disease, why should he remember that? Why I get the disease? That's if you get a problem, you try to find out your reasons for the disease.
But if you don't get a problem,
If you do not get a problem, you will not look for the reasons. So everything is okay. So that's called as a recall bias. Now another is interviewer's bias. Now, interviewer's bias means if I am an interviewer and if I know he is a lung cancer case, he is a control, I will ask questions you more about smoking than this person. So this is my bias. So I am getting more information from you than controls. Maybe controls were equally smokers. But because I already know the case and controls, I am asking you more in depth than the other person. It's called as interviewer's bias. So you get an exaggerated among smokers and less among the non-smokers. And then selection bias means which cases which you are picking up for that thing. It's called, because we don't have a time, I would have defined all these parts, but I will not be able to, and I will be taking it separately. So simple here, you have to understand that we can have a recall bias, we can have an interviewer's bias, we can have a selection bias, we have another bias is called a measurement bias. We'll talk about that. Here this slide is not here important, it's important there, and we'll talk. But you should understand that these are the problems mostly encountered in case control study. So what were the advantages? What are the advantages? It's easy. Cases have already occurred. Also, you have only take history. You may take only from the case sheets. So it's easy to conduct. So if you are planning, you have a good plan because it's easy to conduct. No attrition. What's attrition? Any idea? Attrition means, for example, I have this group. For second year, when I reach the third year, many of you do not come to the third year. Some people drop out because of reasons. Maybe some fail, some leave, they will not off their block. This is called attrition, lost to the follow. Now here is no chance. Similarly, if I take a study, all of you I want to study, then for 1 year, in 1 year I will say some of you have migrated to other places. So I'm losing those numbers. So this is called attrition or loss to follow-up. But here is no follow-up.
Yeah.
You will not lose them. They are already there. You have the cases, it's already in the file. So you have no chances of that. And gives fast results. So you have not to wait for too long. You can just collect the data and start analyzing. It's inexpensive. There's less money involved rather than a study which will go for years together. Or a cohort study which we'll be talking next time. So that is expensive, this is inexpensive. This is also suited for diseases which are newly identified. For example, you have the MERS. When the MERS came, there was a descriptive epidemiology on that. Then they carry out this case control study to find out that was it really the cause. And what they come out that those people who are very close contacts with camels do develop the disease. And this was only because of the case control study. Because this is a newly identified disease, and this is case control study is suitable for that. Suitable for disease who have a long latency period. Because you cannot, if you go forward looking study, this group I had to follow for 10, 20 years. It's a long, huge time. Rather than I will take up case control study, it's very easy. Because here I don't have to wait because disease have already occurred. In other type of study, I have to wait for the disease. More than one risk factor. So you can not only check only one risk factor, you have more than one risk factor which you can evaluate. In comparison to the cohort study where you have only 1 or 2 exposures and you try to find out that where these we'll see in the cohort study. And there are many ethical problems. You are not dealing with people. You are only dealing with with either case histories or even the cases, but you are not doing so much of intervention. there are less ethical problems. Disease have already occurred. But there are certain disadvantages. One, subject's memory. It depends on the subject's memory if you are interviewing the case. This is one of the problems. He may not remember it well. The case may remember, the controls may not remember. So you will get an exaggerated estimate of odds ratio in cases than in controls. Sometimes it's very difficult to find an appropriate control for that case. If I have a case of 45 years, for example, male, I may not get a 45-year-old male without a disease. He may not be interested to come into your study. So it becomes difficult that way. And we can only establish an association. This is only, as I said, we are only finding out an association between the two factors, between the cause and the effect, but we cannot establish what comes first. Did the disease come first, or did the cause come first? We don't know it. While as in cohort study, we can find out that there was a cause that led to an effect. But here, we are only searching for the risk factor. We do not know what comes first. This part will be dealt when we will be talking about causality. And case control designs can't calculate the relative risk. This relative risk we calculate from a cohort study, not in the case control study. So this case control study may not be feasible for this type of study. Now, so that's clear now? Case control, any problem with that? No. Now, most of you are involved in this type of designs. This is called as a snapshot. If I take a picture here, so at one point in time, I am trying to find out how many of you have hypertension, the effect, and how many you are smokers, the cause. This will give me one time association between the two factors. So I am asking, seeing whether he is hypertension. Yes, I am a hypertension. Are you a smoker? He said yes or no. So if I take it one time, this is called as a cross-sectional design. So what does it measure? It measures the existing disease and the current level of exposure. What is the level of exposure this time? They also prove some association. It also helps us to find out the association between the factors. So cross-sectional studies we sample the people without the knowledge of exposure. We don't know how many you are exposed or how many you are not exposed to smoking. So we take a sample, we don't have any information about this. We just ask, you are hypertensive? Yes. Are you a smoker or non-smoker? Do you go for a physical activity? Do you not go for a physical activity? So we'll see the relationship between the two. So sample at one point in time means a snapshot, and they are also called as the prevalence studies. Most of you will be carrying out this type of study. Yeah. So as I said, it's a snapshot. So one time is still. While as another study is called the cohort, which we'll be talking about, that is a picture. For full 2-3 years you are following the case. So the cohort is a picture, full length picture, while as this cross-sectional study is a snapshot, a still shot. You might be knowing when you watch movies, no? The full movie running from 3 hours, so that's a cohort study, and when you are still shot in that, that's the cross-section or the problem. What is happening that time? Okay. For example, same situation. So if you have smokers and non-smokers, and we are seeing the coronary heart disease, do you have a coronary heart disease? Yes. Are you a smoker? Yes or no? So you are filling up these tables. Then you are getting a prevalence among those who are smokers and among those who are non-smokers, where the disease is more. Simple. I think this is sufficient. So we have a snapshot. It measures exposure and the outcome. And the main outcome measure is the prevalence of the problem. Thank you very much for your time. If you have any